Thank you so much, Gilles. Now the floor is open. Would you prefer to answer each question seriatim or all together?
Together it's easier.
Yeah. Okay.
Because I can forget some of them if I want.
Okay. Please.
Well, thank you very much for the brilliant talk. Just a remark. When you speak about instinct for machine learning, for deep learning, for example, it's true, but it's not only that, because we use, in fact, a mechanism, an algorithm, which is supervised. I mean, supervised by linguistic labels, by language, finally. So, could you react to that?
Thank you. So would you like to correct?
Okay, I can answer this one. It's true that even in machine learning algorithms, we do use languages. So as you said, we use language to express labels. But it's also true that as eventually we have to compute distances and compute means and compare numbers and so on, we also use the language of numbers, which is a very simple language, but yet it is a language. So it's not the case that languages have been completely eliminated in machine learning, but they don't play a central role as they do in formal methods, for instance. So it's more a quantitative than a qualitative difference.
Quick.
Just a short answer, but it's fundamental because we can do, stupidity learning if we have not the right level and we have not the right corpus to train the machine.
Yeah, of course.
Yeah. Craig, and then Stanislav, and then Marcus.
Yeah.
Please.
I mean, there's a whole line of philosophical argumentation that maintains that there is no non-linguistic representation. Right, so I think Wittgenstein really worked on that. So I'm just wondering, you seem to presuppose that there's this nice, neat separation, and when most think there isn't, but maybe the way of dealing with it is to distinguish different sorts of images. All right, so in sort of Aristotelian terms, there would be the external image resulting from an immediate external sensation, and then there's images of a more internal sort. So that's just...
Yes, of course. If you speak of representation, then by using the word representation, you put language in it. So the idea of, I think you refer to Fodor, that every representation is linguistic. In some sense, it's a tautology, because if it's a representation, it's linguistic. But I'm not speaking of representations here. I'm speaking of processes. And you do have processes that are non-linguistics. For instance, if I switch on the light by pressing the switch, this is not really linguistics. It's not really a symbolic process to press a switch. Okay, you can say it's a language 0-1, but it's a very poor language.
Thank you. Stanislas, please.
Yes, I like very much the distinction that you introduce. I think it's quite fundamental for the human brain that there is indeed a sort of symbolic level. Of course, it's an approximation, and I think you're right. It's approximated by neural networks, but still it's a good description of that level where at the conscious level we compress the information as symbols. And you mentioned two arguments for why perhaps we evolved such a system. One is that we sometimes need to make very fine distinctions between things that look alike, and the other is we like to explain things rather than just predict. I think there is a third argument, and it's very important for human evolution, is that once you have the symbols, you can communicate them to others. And I think our species in particular has exploited this ability, and it's remarkable that the machine learning which is occurring at the moment, the machines have a lot of knowledge, but they cannot communicate it to anybody outside.
Yeah, my answer will be short, yes.
Good. That is very short indeed. Congratulations. Marcus, please.
Yeah, thank you very much. I have a question about the painting business, right? I mean, so imagine I have a Picasso and a fake Picasso painted by someone else. Could the machine distinguish them? And what I mean is this, right? Even the best fake painting will differ from a Picasso painting, and we can detect this with chemistry, we look at the brush and so forth. So I think it's false that paintings are identical to patterns, right? Unless you take into account the chemical patterns and so forth, the depth of the brush used at the time, the way the history of the painting on the wall and so forth. So is this taken into account in machine learning? Otherwise, it would be very easy to fool the machine learning system. And so you could demonstrate that the machine learning system is incredibly bad at distinguishing a Picasso from a fake Picasso, and therefore at identifying a Picasso.
Yeah, it's something, okay, Picasso is not a very good example because Picasso's work are very diverse, okay? But take Vermeer, for instance, and it's something where humans and machines are very much alike, is that they have been fooled by fake Vermeer. And so machines are very like us. They get fooled all the time. We have not. We have identified them after years. So it's a very difficult task. So machines are bad at it, as we are.
Thank you. Maggie. And then Pierre.
Have I got this working? Okay. Just a quick word. My apologies for not being here to say welcome, so I say welcome now. I was busy being sick this morning, I'm sorry. Actually, I'd like to ask you a sort of historical question, which hangs on the work of Piaget. And as you probably well know, he kept a diary on his children and their development, and this is all from Petit Henri's diary. And Piaget hit the problem of the conservation of matter, which is absolutely central to logic and everything else, and wrote a later book called Contradictions. And what was interesting is that the two categories that you have presented are very useful in some respects, very useful indeed, but I think there's a missing concept, which is logic. Because in that book on contradictions, he says something that I think is still completely relevant today, which is that if those children were asked why they had said that there is more water in the tall vessel than the small vessel, we all know this, they will give reasons for it. And those reasons, I'll stop, they're neither instinctual nor are they mathematical. They're logical. Mm-hmm. So is there a case to be made for a third category here?
Of course, I didn't use the adjective mathematical at all, and I spoke about a linguistic explanation. And within the linguistic explanation, there are the logical explanation. So of course, we know that language and logic come from the same root. It's the same word. But I wanted to take the broader work, so I didn't use logical, I used linguistics. And within the logical, there is a mathematical. But yes, the explanations are logical sometimes, sometimes not. And this is how they appear in my talk when I speak of an explanation. Logic appears twice. When I speak of a language, of course, I have in mind among languages the languages of logic, of predicate logic. But also when I speak of an explanation, I have in mind the other aspect of logic, which is reasoning, proofs, and so on.
Thank you. The last question is from Pier Paolo. You wanted to add something?
Just one thing.
Yeah.
Well, you used the word symbol for all your examples, in particular for both numbers and images. Now, I wonder whether it would be useful to distinguish between signs and symbols. because they are two very different things. So machine learning can recognize signs, marks, but symbols are not an aggregate of signs. They exceed signs that in a certain way also more complex and indeterminate. So I wonder if it would be useful to distinguish between signs and symbols in your paper. Thank you.
Okay, so I think I have answered this question in a book, but the book is 200 pages, so I'm going to try to be shorter. I think that the main difference is not between signs and symbols, but between natural languages and formal languages. And we could speak of signs when we speak of both kinds of languages, and restrict the use of the word symbols when we speak of formal languages, like the language of numbers, the language of music, the language of logic, the language of equations, the language of molecules in chemistry, and so on. So we can use the word symbols just for this particular case and have a broader notion of sign that includes natural languages.
Thank you. Thank you. Perhaps we can postpone to the general because it's already time to the general discussion at the end. Thank you very much.